Okay, this is a quick video on similar triangles. So in this particular case, the statement here reads triangle ABC is similar, that's what this symbol here means, is similar to triangle DEF. And because these are given to you in this particular order, we can tell a lot from this information. We can see that because A and D are both first in this notation, that means angle A must be congruent to angle D. And because angle B and angle E are both in the middle, we can say that angle B must be congruent to angle E. And then because we have C and F in the last position, then we know that angle C must be congruent to angle F. Now the other thing we know about similar triangles, we know that their angles are congruent, right? That's what we know. Angles are congruent. Actually, it's called corresponding angles are congruent. And we know corresponding sides are proportional. So this word that would have to go here is that word corresponding. Now that's really important because we want to make sure that we are actually comparing side lengths that are in corresponding locations. Okay, so when we are given this and we know that we've got these triangles, if we drew them out, because it's always great to draw pictures, we've got triangle ABC, and down here we'll draw triangle DEF. Okay, well what we know is that angle, what was that? Let's just back up. Okay, what we know is that angle A and angle D are congruent. These angles have the same measure, so we have one arc for each of those. And angle B and angle E are congruent. So I have two arcs here, and I have two arcs here. And then angle C and angle F are congruent. So we'll put three arcs here, and we have three arcs here. Okay? And so then our sides must be proportional. So I can see that side AB, or segment AB, is between angle A, which is our single arc, and B, which would be the double arc. So side AB divided by side DE, because this is between the single arc and the double arc. Okay, so AB divided by DE must equal, now let's go between 2 and 3. So between this 2 arc and 3 arc, right, is side BC, and over here it's side EF. Okay, and then we're going between 3 and 1. So 3 arcs to 1 arc is side CA, and here it's side FD. Now, if we just are looking at these in order, we can do the exact same thing. AB, those come next to each other. DE, they're the first two letters. AB and DE, that's where they come from. Okay, and then let's say BC and EF, they're next to each other as well. BC and EF. Okay, and then the trickiest one, and it's not super tricky, but it's the trickiest of them, is going from side C to side A and F to D. Okay, C to A and F to D. Now when you're asked to fill in a statement that says triangle ABC is similar to, or you can prove that it's not similar, you actually need to put the vertexes in the correct order. They must match. You must have corresponding angles. So these angles, or these vertexes, must be in the right order for it to work. Okay, so if we look at one of the problems on your page, we've got these two triangles, and we have that this angle here is 55 degrees. We're not given this angle here at G. And here at this vertex of S is that this angle here and this angle here have to be congruent because they are vertical angles. And we know vertical angles are congruent to each other. Okay, so we've got that these angles are congruent, and we have that this is 32 and this is 56. So we could figure out this angle because of that triangle sum theorem, but it's not necessary. Remember that triangle sum says that 32 plus 56 plus this unknown here must equal 180 degrees. Well, we can determine what that is, but we know that these are the same, and all we need are two angles that are congruent to prove that these two triangles are similar by the angle-angle similarity theorem. But the fact is this says 55 degrees and this says 56 degrees. And so we only have one congruent angle. And so because we don't have enough congruent pieces, right, we can simply say that these two triangles are not similar. Okay, but let's look at another one. What if we had a question that gave us this information here? We've got that these lines here are parallel to each other. Okay, you're given that. This is K and L and J and F and E. And I want to know triangle JKL is similar to what triangle? Okay, so right away we can see that this angle here and this angle here are congruent because they are vertical angles. Okay, we know that this line here, EF, or segment EF, is parallel to segment KL because of this symbol here. So we know these lines are parallel. Okay, so because they're parallel, we can see that this would be a transversal. Remember, a transversal intersects parallel lines. And when it intersects these parallel lines, it forms these wonderful angles. And we know all about these wonderful angles. So what we know is that this angle here I need to be in pen format. We know this angle here must be congruent to this angle here. Okay? And that's by alternate interior angles. They're on opposite sides of my transversal, but on the inside of these parallel lines. Okay, so we know that these angles are congruent. Well, we also know, because these lines are parallel, if this is a transversal here, which it is, that we also have that this angle here would be congruent to this angle here. Okay, so we've got J, K, L. That's what's given here, J, K, L. So we need to go in the same order. So J has one arc. So on this second triangle, J also has one arc. So we have J to begin with. Now K is our next vertex. K has 3 arcs. So we want to go to F, which also has 3 arcs. And then L has 2 arcs. So we want to go to E, which has 2 arcs. So triangle JKL is similar to triangle JFE. Now again, it is very important that you put the vertexes in the correct order.